Are we rolling? Let's go. All right, class, so what we have here today is a very valuable means of demonstrating a wide variety of physics concepts. So cars can demonstrate forces, energy, momentum, and all of that jazz. But what I really want to talk about today is the physics of rotation. But I suppose before we can get into that, we should go all the way back to ground zero with kinematics, the description of motion. So what I've set up here is 3 traffic cones, and we're basically going to practice a very basic kinematics problem with that. By the time I reach that first cone over there, I should expect to reach a speed of about 10 kilometers an hour, 2.77 meters per second, and I will try to bring myself to a stop by that last cone. So your challenge is to determine the average acceleration it takes to bring me to a stop over at that cone there. All right, let's go. And stop. So, I'll give you some time to figure that out. You can pause the video if you need to. Yeah. All right, after using the equation v final squared equals v initial squared plus 2a delta x, you should have gotten an acceleration of about negative 0.38 meters per second squared. Now, switching over to rotational kinematics from there is actually pretty easy, because all you're doing is really just swapping linear quantities, so displacement, velocity, and acceleration, with rotational ones. Angular displacement, angular velocity, and angular acceleration. And the way you do that is just by dividing the linear quantities by r. The radius of the rotating object, in this case a wheel of our car, which is around 0.305 meters. So, if we were to try a similar demonstration to the last one, but with rotational quantities instead, if we have a linear velocity of 2.77 meters per second, we'll have a rotational velocity of around 9.08 radians per second. And this time, instead of some amount of meters in terms of displacement, we'll have an angular displacement of 8 pi radians, which is 4 rotations of the wheel. And my cameraman will step out to keep track of it. Alright, that should have been fairly easy. You're just using the same equation as last time, but with rotational quantities substituted in. You should have gotten an angular acceleration of negative 1.64 radians per second squared. Now this time we'll do everything the same as last time, but we'll go 5 rotations instead. So my cameraman will step out once again to keep track. Oh my god. Hey, are you alright?
Hey you, stop right there. Do you have any idea how fast you were going? You were going 6 miles an hour in a 5 mile an hour zone. My god, did you hit this guy?
Okay, I know this looks bad, but I swear I didn't.
Then who killed him, huh? My mother? You're the only one around here.
Come on, you've got to believe me. All of my demonstrations started at 10 kilometers an hour, which you know, given that you cited me for a speeding violation.
Likely story, pal.
I applied a force of 2,284 newtons for 2 seconds,
Save it for
which
the
means
judge, pal.
that I had to have created an impulse of 4,000 568 newtons. I know that the mass of my car is 1,649 kilograms. Because of the laws of conservation of momentum, my car had to have stopped within 2.8 meters right before the body.
Yeah, okay, pal. You have the right to remain silent.
Hold it right there. I wouldn't take him away just yet.
And you are?
Detective Herlock Sholmes. Homicide. I suspect this may be more than just a simple vehicular accident.
You're a detective, huh? And I'm the President of the United States. This is clearly manslaughter.
Manslaughter, yes. Or murder. As the professor stated, this car was not how the victim met his tragic end. But then, how was he killed? I believe our answer lies with this.
A head wound? I'm sure he got it when he fell.
I wouldn't be too sure. As you can see, this wound is on the back of the head, but we know the victim fell face down. This means that some kind of object would have had to cause the trauma. Now, based on the science of collisions, there are a couple of possibilities of where this object could have gone, all known as the property of elasticity. Now, in a perfectly inelastic collision, and the object would have become embedded in the wound. But as you can see, there's nothing there. As collisions become more elastic, the respective motions of their objects differ. In a perfectly elastic collision, the object could have rebounded in the opposite direction with the same momentum that it started with, assuming that the velocity of the body changed to conserve the momentum.
That only happens in particle physics. Most collisions have some degree of inelasticity.
True, but we still can't approximate the collision as elastic, which means that the object should be somewhere around here. Judging by the nature of the wound, it seems as though it should be of a small, round shape. Aha! We have our murder weapon.
An orange.
You're telling me that a goddamn fruit is our murder weapon?
Well, it's the only possibility. There's nothing else around here. Besides, I have no doubt that even an object of such a small mass could amass enough kinetic energy to kill a man if launched with a high enough velocity.
Sholmes is right. Kinetic energy is calculated as the product of half of an object's mass and the square of its velocity. Velocity is actually inherently more influential on an object's kinetic energy.
Knowing that about 100 joules of kinetic energy is enough to inflict fatal skull fractures, an orange that weighs about 184 grams would be lethal if launched at a velocity of around 33 meters per second, or 74 miles an hour.
Some baseball pitchers have thrown fastballs at speeds of over 90 miles per hour. An orange traveling at 74 miles per hour or faster is perfectly within the realm of possibility.
Which means that at this point we have answered the question of how, and eliminated our good professor here as a possible suspect. The only thing that remains now is who done it and why. Officer, I believe we are slowly peeling the bitter rind of mystery off of this case.
Are you tired of normal, boring roller coasters with only one loop? Then come on down to Super Silly Funland and experience the all-new Super Duper Duper Looper. With 2 loops, you'll get double the centripetal force and maximum fun. Our revolutionary design uses frictionless tracks to point all the force towards the center, meaning you'll get all the thrill you can handle, and more. So what are you waiting for? Come down to Super Silly Funland today and experience the rush of the Super Duper Duper Looper. Super Silly Funland. Super silly, super fun. Super Silly Funland is not legally responsible for any injury or death that results from riding the Super Duper Duper Looper. The Super Duper Duper Looper may sustain a lethal amount of G-forces to any riders. Super Silly Funland is not to be held liable in any circumstances where a person is deceased from an excess of fun.
Detective Sholmes, if a projectile orange was the murder weapon, then where did it come from?
Well, we know it can't have come from in front of that bush there. The killer would have been seen, or at least left some signifier of their existence.
And if it was shot over that bush, then we know that they would have wanted to be close enough that they could still closely track the victim, but far enough that they wouldn't immediately attract attention.
If we set the angle of launch between a reasonable 10 and 80 degrees, we should be able to calculate the amount of distance covered by the orange using the power of two-dimensional kinematics.
Listen, I don't have time for all this physics shenanigans. I'm going back to the headquarters to report this.
Well, unfortunately for you, our writers assumed that my calculations would be done in negligible time. As you can see, the orange would travel a horizontal displacement of 38 meters at both extremes. This is because the angular relationships of both triangles are the same, only the direction of where the orange has its fastest velocity changes. We actually find our greatest horizontal displacement at the center of those two extremes, when the launching device is angled at 45 degrees. We get a horizontal displacement of 111 meters.
That's an awful lot of math for something we could have just found out by, I don't know, walking past that bush.
Well, in that case, let us proceed then. Onward! Professor, how much farther?
Well, if we continue along this course, we'll probably take a few hours.
You're telling me you jokesters got lost?
Guess we better change our course then. All right, this way. What do we have here? Dear God.
Well, I guess we found where the orange was shot from.
Hey, detective, look over there.
Well, would you look at that? Hey, you there!
I'll handle this. Official police business, you two. Come with me, please.
What's this all about? You better have a good reason for calling us over here.
Calm down, calm down. Now, gentlemen, we have reason to believe that one of you is guilty of the crime of murder in the first degree.
Well, I was just playing with my yo-yo. You see, as you extend the length of the string, the time it takes to complete one oscillation, or the period, increases. Funnily enough, that's the only thing you can do on Earth to produce any meaningful effect. The mass of the bob means nothing, and the angle of release means nothing as long as the small angle assumption is maintained. This intriguing reality is reflected in the equation for a pendulum's period. 2 pi multiplied by the square root of length divided by the gravitational constant. We would have to travel to a whole nother world to counteract the power of length.
Okay, that, checks out. What about you, sir?
Well, you see, I was just trying to pack these boxes into my car, but I really hurt my back.
Why did you use a ramp?
Well, I figured the work would be lesser, since it's divided over a larger length.
Well, that's not quite how that works. You see, since friction isn't negligible in the real world, as you apply a pushing force to this box up the ramp, the box meets frictional forces from the surface of the ramp, resisting it.
Aw, jeez. So you say I've been working harder this whole time?
I'm telling you that you're an idiot. What kind of moron would account frictional forces as negligible?
A pretty stupid moron, I suppose.
Yes, well, both of those alibis seem to hold up. Okay, gentlemen, you're free to go.
Great job, detective. You just let our 2 biggest suspects walk on out of here. And last I checked, you weren't any closer to solving this case. You ought to just go home. I'll handle it from here.
Hold on a minute. There's still one suspect I haven't ruled out yet. With all due respect, officer, what were you doing at the time of the incident?
Me? I was just doing my rounds. I'm on patrol for this neighborhood.
Is that so? Where, pray tell, is your vehicle then?
Questioning me? I don't have to tell you anything. I'm the authority here. You're overstepping your boundaries, detective.
On the contrary, officer, I believe it's you who's made the wrong step. I had my doubts before, but it's clear now. Professor, the true culprit of this crime and the one who tried to frame you as its perpetrator has been right in front of us this entire time. Our killer is none other than this fraud putting on the face of an officer of the police.
How did you know? I hid it so well.
It's simple. No one was scheduled to patrol this neighborhood. But you already knew that, of course. That's why you chose today, in this specific location, to carry out your evil deed. You obtain the necessary information, uniform, and equipment to commit your crime. It was all going according to plan. You stake it out with your cannon, waiting for some poor sap to come by and see a body on the ground. No one around. No one to testify for him except you. It was the perfect opportunity to set up whoever drove by as the one who murdered our victim. But there was one thing you didn't account for. Me. You didn't think you would have to give your own account at all, being the one in authority, as you put it. Caught off guard, you slipped up and forgot the biggest factor that allowed you to do this in the first place. It was your own devious plot that inevitably brought you to the ground. My only question is, why?
You could never understand. For me, oranges are everything. I love their roundness, their citricity, the way the peel gets under my nails. Oranges should be eaten the right way, the only way. And when I saw that this psycho took a bite out of it, I was furious. I watched him from afar, day after day, week after week, to see if he would ever change his ways. But it was fruitless. He just continued to bite and bite and bite. I couldn't take it anymore. I had to get rid of this guy. And I would have gotten away with it too, if it weren't for you and your meddling physics.
It's over, officer. I've already called for backup. You're going away for a long time.
Curse you, physics!
Well, that's finally over. Thank you so much, Detective. There's something that's been bugging me, though. Where did he ever get a cannon?
Suppose that mystery will have to be solved another day. I seem to have grown a nice appetite for a fruit salad. What do you say?
Lead the way, Detective.